This is our lesson. It is a review on right triangle trigonometry. Our focus when we test is going to be all application questions, guys. We're not going to have these baby questions where it's like a random triangle and you got to find the hypotenuse. It's going to be an application story problem. So if I put this symbol in the corner here, that means it's a right angle, so we have a right triangle. And if I physically stand at one of the angles, let's pretend I'm standing right here. Here I am. That's my angle of reference. So this is the angle. We're going to call it theta a lot today, but maybe in Geo you called it just x because they didn't want to scare you with the variable theta. Theta is a Greek letter. It's just a variable. Okay. And the side that is across from the 90-degree angle is always known as the hypotenuse. But if this is where I'm standing, what do you call this leg? Good, it's next to you, so it's the adjacent leg. It's not the hypotenuse because it's not from the right across from the right angle. But the angle across from me, we call the opposite leg. So then your geo teacher told you some sort of mnemonic device for what to remember for our 3 trig functions. And most of you learned SOHCAHTOA. So can you remind me what SO stands for? Sine of an angle is opposite over hypotenuse. And CA stands for?
Adjacent over hypotenuse.
Good. Cosine of an angle is adjacent over hypotenuse. And then tangent of an angle is opposite over adjacent. So taking sine, cosine, and tangent of a particular angle in a triangle is going to set you up a trigonometric ratio is what we call that. It's a fraction. Now, depending on where the variable is located, sometimes we know the angle, sometimes we don't know the angle. It's going to depend on how we algebra students solve for it. So everyone check that their calculators are in degree mode today. And on your paper, you have these little formulas at the top, and then we have some problems to look at. So, guys, even when I teach this in pre-calc, which are like, pretty high-level math class, I still literally draw a smiley face where my angle is located. So this is where you're standing. So in reference to this angle right here, how would you label 40? Good, that is the hypotenuse. How would you label this side that has an x on it? It is opposite of you. So if I have the hypotenuse and x involved in my math problem, what would you set up? Good, that is a sine question. So we're going to set up the sine of the angle, which I know is 60 degrees, is opposite over hypotenuse. So x over 40. So ladies and gentlemen, you have a proportion to solve. How do you solve proportions? Cross multiply. So x times 1, that's easy, that's just x. But this is something I'm going to have to type on my calculator. Sine of 60 multiplied by 40. Can you please be careful that when you open sine 60 that you close the parentheses so you stop the sine function? And type that in, and I'm going to have a decimal probably. Oh no. And 0.6?
Yes.
Alright, yeah, it doesn't tell me where to round, so I'll go with 34.6. Thank you. 10th place is good for us today, guys. Remember doing a bunch of those in Geo?
Sure.
Whole bunch. Oh, this is some good stuff. Alright, so number 2. Again, I know it seems babyish, but I think it'll help us in the long run, guys. There you are, standing at 25 degrees. Alright, so here we're standing, and then they labeled this leg as 40. How would you describe that leg that's adjacent to you? Good. It's next to you, but it's not the hypotenuse. Who is the hypotenuse? Good. So if you have the adjacent and hypotenuse as clues, we should be setting up cosine. So cosine trig ratio says cosine of my angle, 25, is adjacent over hypotenuse. Now, be careful on this one. When you cross multiply here, we got to be careful on that part because this is x times cosine of 25 and then equals 40. So this is not really a multiplication question, guys. How are you going to solve for x? Yeah, this is one of those ones we have to divide. You have to be careful on the dividing ones because you have to divide in a particular order. So when you did 4,000 of these in geometry, your teacher probably gave you like a shortcut for what to type in every time, and that's fine. My brain is just done with shortcuts lately, so I'm just doing what I know. 40 divided by cosine of 25 is to the 10th place, please. Thank you. All right, we will do one more, and then we're going to skip around a little bit, because this is clearly review for you guys. You're doing great. All right, so here's your angle. How would you label this side that's labeled x? It is next to you, so it's adjacent. How about this 30? Opposite of you. So what trig function do they want? Tangent. All right, tangent is set up as tangent of 18 equals opposite over adjacent. So this is another one where you got to be careful how you're doing this. We're going to cross multiply. So this actually turns out to be a division question. So we have x times tangent of 18 equals 30. So you guys were telling me to solve for x. We're going to divide by the tangent of 18. All right. To the tens place, please. One more time, dear. 92.3. Thank you. Awesome. So, solving for legs on a right triangle are going to involve one of those three ratios. And you got to be careful. Sometimes it's multiplication, sometimes it's division. So just trust in your proportion cross multiplication. But then what I want you to skip down to is number 7, where it starts number 7. There's this big blurb about, what are we going to do when we have to find an angle. So this question right here, it says sine of some mystery angle equals 0.6427. So if I want to think of this like an algebra student, I have to undo a sine function, because I can't divide by a sine function. I have to undo it with an inverse. Well, what is the way to undo a sine? Is to use an inverse sine. Do you see anything on your calculator that might represent an inverse sine? Yeah, right above the sine function button, it says sine to the negative first power. So that is called the inverse or arc sine function. So what you're technically doing, because I like to think of this like an algebra student, you are applying an inverse sine to both sides of your equation. That's really what you're doing. Now, inverse sine and sine are going to cancel out, and that's why we solve for A. But this is something I have no idea what that is. I'm going to need you to type that in. Can you please type inverse sine of 0.6427? Does it round up to 40? Okay. Wait, well, I'm hearing different answers.
No, it's 39.9.
Did you type the wrong button, maybe? Inverse sine of 0.6427? Of 0.6427? So you found something else. Okay. All right, guys, so this next one. How do I undo a sine function? Same way, right? We're going to apply the inverse sine to that lovely decimal. $86. Sounds good. Very good. So how do I undo a tangent function? Same way, but this time I got to use inverse tangent. Now I'm being lazy. I'm just writing it one time. Technically, we're applying it to both sides, but, whatever. Inverse tan of 1.60033. 58. Thank you. And then, just for good measure, how do you get rid of a cosine function? How do you undo cosine? Same way, but this time we use inverse cosine. 14? Okay. Awesome. Very, very good. So maybe as a geo student, sometimes when you first learn something in math, you're not really sure, the real reason why you're doing something. Just my teacher told me to hit second sine, and then magically the answer pops out, right? But now as an algebra student, you guys know we're undoing the sine function. We're using the inverse sine to undo it. All right. So this time, this time, the angle that I'm interested in, that's all right. I'm good. I love your sine. Thank you. All right. So arc sine, we're going to use an inverse function here to find this angle. I got to figure out which one I'm supposed to use, though. So if this is where I'm standing, how would you label this side right here? This is opposite of you, and this is adjacent to you. So we should be using tangent. Now, if you want to be really official, you would set up your trig function that says tangent of angle A is 36 over 40, And then I'd say, self, how do I undo tangent? I used inverse tangent, yes. So I'd be applying an inverse tangent to both sides. I know some of you are already taking shortcuts on your calculator. I am okay with that. This is what you're going to type in, guys. Inverse tangent of 36 over 40. It'll automatically open a parenthesis. Yeah. You don't have to close it because there's nothing that follows, but it is good habit. What'd you get for angle A? 42 rounds up? All right, that works. Let's do one more and then we'll go to the good stuff, the applications. All right, number 2, we are trying to figure out angle B here. That's what I'm interested in. How would you label 28 in reference to where I'm standing? It's adjacent to you. Very good. How about 31? That is clearly the hypotenuse. So what trig function do we have? Cosine. So we have cosine of, I don't know, angle B is adjacent over hypotenuse. So tell me, how do we get rid of cosine again? Inverse cosine. So you are applying an inverse cosine to this ratio. 25 degrees? Thank you. All right. Degree. Yeah, they got it. Maybe someone was not listening to me when we started our lesson. All right. All right. So, we can do more examples, guys. Oh, jeez. So, what we're going to do now is we're going to take those topics of applying trig ratios to right triangles and we're going to apply them to real life problems. However, we're going to find out most of these are pretty stupid. So, the first one is poor little Mary. She's flying a kite on a 50-meter string, and for some reason, she's literally laying on the ground. Like, do you see this? She's just laying on the ground, flying a kite. Because they don't say, like, if you fly a kite, like, you're going to hold it and stand, right? So what if this was a real problem, they'd be finding the height of where her hand is, and then they'd add up the extra meters or feet from her hand to the ground. Like, don't lay on the ground, people. Just do a little extra math at the end. Anyways, stupid problem. My bad. So here's Mary. I don't draw, you know that. So that's Mary. And she's laying on the ground, and she's holding the string on the ground, and then it's taut because it's a kite, you know. Here we go. There, that's about all the drawing you're going to get from me today. And it says the string makes a 50-degree angle with the ground. So, you got to read these carefully because your job is to draw and label the diagram. So a 50-degree angle with the ground would be this angle right here. Now, consequently, the next clue also happens to be a 50. It's not always that way. Where do I label the 50 if it's the length of the string that attaches the kite to Mary? Yeah, it's the hypotenuse, to use a word, yes, that we know. And the question is, how high above the ground is the kite? So I'm looking for the height right here. So remember, this is Mary, and this, you guys told me, was opposite of her, and this is the hypotenuse. So what trig function are we setting up? Sine, very good. So sine of 50 degrees equals opposite over hypotenuse. So if you already know that this is going to be a multiplication question, that's awesome, but if not, just go through the proportion, guys. This is 50 times sine 50. Is my x, and go ahead and tell me how large the height is. And it doesn't say where to round, does it? So let's 10th place on this whole worksheet. 38. Thank you. 10th place, 10th place. All right, let's see what fun problems they're going to ask us next. Oh, Bill the architect, he's back, and he's making a parking garage for the city. So they've already labeled the diagram for you. That's nice. The height between the floors and the parking garage is 10 feet, and the ramp itself here is 75 feet, and they want you to find the angle of elevation. Because I don't know if you guys have been in parking garages, but they can be a little scary if you don't have the right size vehicle. And have you ever been in a parking garage that's like super steep? You guys don't really drive in parking garages anymore? I have. It's terrifying. Do you imagine that maybe when they're building a building, they have to be careful about, they call this the grade, the incline. Like, can you have a 60-degree angle of incline and be safe for cars?
No.
Probably not. I mean, I'm not a civil engineer. My brother is, though. We could ask him. Should we get him on the phone and find out? Yeah. All right. I'm sure they have code, guys. They got to stick to a certain code. All right, here we go. This is your angle of reference. So if you want to think of it as you standing here, you can. But how would I label the 10 as far as where I'm standing? It is opposite of me. And then what's this? That's the hypotenuse. So what trig function are we setting up with opposite and hypotenuse? It's this, so it's sine. Very good. So the sine of, this time I don't know the angle. So sine of, we'll just call it x, good, equals opposite over adjacent. Or sorry, opposite over hypotenuse, excuse me. So we're going to undo sine. How? Inverse sine. Very good. I'm going to cheat. I'm just going to write it over here. Inverse sine. Oh, I guess I can write it over here. And tenths place, please. Very good. Oh, 0.7? Rounds to 7? Thank you. It might make the difference between life and death, girl. You got to be careful. All right, 7.7 degrees. Moving on. Oh, I love this question, mostly because everyone gets it wrong. Okay, so we have a lighthouse. I know, right? It's a good math teacher. My pre-calc kids got this one wrong when I first introduced it, so don't feel bad if you guys set this up wrong, because this is, I don't know why, but everyone gets confused with this one. All right, so at the top of a lighthouse, which that's my lighthouse today, deal with it. I don't drop, you know this. The angle of depression to a buoy is 25 degrees. So when they say angle of depression, they're referring to someone way up in the sky. So like here you are, whoops, looking down at it, but you, when you're up here, you have your own horizon. Like you're way up tall, right? So when I'm looking down to the buoy, this right here is the angle of depression of 25 degrees. So what's the problem with me saying 25 degrees in this problem and using this angle right here? It's not even in my triangle. But think about your other geo knowledge. Yeah, all right. Let's make your geo teachers happy. Who remembers why this is also 25 degrees?
Something about the opposite. I don't remember what it's called. I just know that it's the same.
Alternate interior angles. They are on opposite sides of the transversal, but on the inside of the parallel lines. Alternate interior angles are congruent. High fives to all of you who got it. Nice job. Okay, anyone remember what this angle is called? In trig. So if this is the angle of depression, this guy down here is called the angle of elevation. Okay, elevation means to look up at something. So here's what I'm going to tell you guys. Angle of depression is at the top of the triangle, but outside of it, angle of elevation is in the bottom of the triangle. They're always the same angle because of alternate interior angles. So my brain, whenever I see angle of depression in a problem, my first response is to write that down at the angle of elevation and just be done with that part. Okay? So angle of elevation is actually 25 degrees. Now there's one more clue here. It says the top of the lighthouse is 150 feet above sea level. So that would be this height right here. And they want to know, now be careful, the distance from the buoy to the foot of the lighthouse. Where should I put X? The bottom of the triangle. Very good. So even though I'm technically standing here, this is where I'm measuring from for my trig ratio. So here I am. I'm at the buoy all of a sudden. And we have an adjacent and opposite, which is tangent. Very good. So tangent of 25 equals opposite over adjacent. Now be careful, guys. This is not just a multiplication question because of where the x is located. So if you think about how you're solving this proportion, you got x times the tangent of 25 equals 150. So it turns into a division question. You're going to divide by the tangent of 25. To the tenths place, please. 321.7. What's my label on here? Feet? Very good. All right. Good, good, good. That's that. Okay, number 4. At a certain time of day, the angle of elevation of the sun is 44 degrees. Okay. We have a length of a shadow cast by a building that is 30 meters tall. Okay, here's my building. Very good job, Abruzzo, as always. This is why I don't teach geometry. You see what I'm working with? All right, so there's the sun over here. Woo. Yep, that's good. That looks like a spider. There's your sun, and it says the angle of elevation of the sun is 44 degrees. Now, guys, this is a little confusing. If the sun's shining down on the building, it's going to create a shadow. I know this sounds dumb, but where are shadows located? On the ground. Thank you. Do you know how many kids?
Mine's
like,
technically right.
Oh my gosh.
It's not on the ground if you're not on the ground.
Well, okay.
It's on the thing that your feet is.
Here's my question. Would a shadow ever be here?
No.
Okay, then why are kids putting it there when I set up my problems for me?
I don't know.
All right, guys. So the shadow is what they want. The shadows are on the ground in these questions, guys. Don't get tricky. And then it says the angle of elevation of the sun is 44 degrees. And angle of elevation of the sun, what that means is if you were on the ground looking up at the sun, that's the angle that you would tilt your head. So where do I put 44 degrees in this picture? Ah, yes, down here. This is 44 degrees. And the 30 is the height of the building, which clearly that fantastic drawing is the building. So what trig function are you seeing here, guys? Tangent, very good. Tangent of 44 equals 30 over x. All right, Skippy, hold on. We're going to cross multiply. And some of you already have the shortcut. You know when to multiply and divide. That's awesome. Maybe I don't yet. So x times the tangent of 44 equals 30. So then you're going to divide. What's 30 divided by tangent of 44? 31.0? 31.1. What's my label? Meters. Very good. Okie dokie. Let's do something that's super fun. Turn to the back. I don't know. 9 looks super fun. Well, you can do it by yourself if you don't want to do it now. All right, guys. So remember Mary and her stupid problem where she was lying on the ground to measure the kite? And we were like, that's really dumb. Like, why would you stand on the ground? Or like, why would you lay on the ground to measure this? So when they have surveying questions, gentlemen, this picks you up, be quiet. When she's measuring something, like, it would be dumb of her to literally lay on the ground. Like, there's no point to doing that. So this is how surveyors actually work. Have you ever been on the side of the highway and there's like workers along and they look like they're measuring something and it looks like they have binoculars almost. You ever seen that? Sometimes they put them on tripods. Those are surveyors and they're using trig to indirectly measure things. So those special binocular looking things measure angles of elevation and whatnot, and they can measure distances as well. But if you guys think about like real life, like if you want to do, like my brother, he's a civil engineer, he works on large highways like in Chicago. So are they going to like stop traffic on I-90 and be like, wait, we got to figure out how far across it is from this point to this point? Like, no, they're not going to stop traffic. So they have to indirectly measure everything when they're setting everything up. Yes, Mike? They look like binoculars, right? So they actually can measure horizontal distance, yes. Well, they can measure horizontal distance to a point, I should say. But what they're really doing usually on these little binocular dudes is they have a focal point that's on the horizon, and then when they like look up at something, it measures like a protractor would. It's like 23 degrees angle of elevation. I mean, because you're not going to bring a protractor out. I've never seen anybody in real life with a protractor. That's silly. All right, so here we go, guys. This is what a surveyor typically, not this particular action, but this is how it works. So they're not going to lay on the ground because that's demeaning. Grounds are dirty. They're going to stand up using their little binoculars. And he's trying to figure out the height of this structure. And he knows, because he can measure physical distance when he walks away. He walked away 100 meters. That's how far away he is right now. And using his binoculars, or whatever they're calling them, it's a 23-degree angle of elevation that's labeled on your picture. So can you see? I know your picture's really tiny, but this is the dude right here. And I think we could find some stuff. Can we find the length from here to here? Yeah. Using what? Tangent. Very good. Whoops. So we have tangent of 23 equals x over 100. So you are going to be multiplying 100 times the tangent of 23. What'd you get? 42.4? Okay. So am I good? Is that my answer?
No.
All right. Not quite, right? Because that's just from here to here. But remember, he was not laying on the ground. So now we have to incorporate the distance from his binoculars to the ground. That was an extra 1.55 meters. So add those in. It rounds up to 44 meters. That works, yeah. Yeah, and you know, when you do multi-step math, the more truncation you do, the less accurate your answer. So like, he was keeping his numbers in his calculator the whole time, and that works out great. All right. Okie dokie. Keep moving. Oh, this is fun. So a 500-meter radio tower, they have to secure it against against high winds. So they're going to put anchors, and you wouldn't put it at the top of the tower, right? Because what would happen if you have a really long, skinny piece of metal, and you attach a big wire to the top, and then it flexes in any way? What would happen? It's going to snap, yeah. So they attach it at, someone who knows way more than me knows when to attach it along the height, but they attach it somewhere else on the height, and then they create a bunch of triangles. So let's see what's going on here, guys. It says the wires form a 15-degree angle with the tower. So, oh boy, that's a lot of things happening here. I think what we need to be looking at, and this is like too ugly of a picture for me to look at right now. I think this middle line, let's just look at this triangle. I'm going to draw it over here because my pictures are so much better than theirs, right? All right, 15-degree angle with the tower. Notice they already labeled that for you. Would you have put that 15 degrees right there? Would you have known to put it there? A lot of kids don't. So if you put the angle in the wrong spot on the triangle, do you remember what that does? It gives you a very wrong answer, so be careful. All right, guys, it says it's 500 meters, but what is 500 meters? The entire tower. So I don't know if it's appropriate for us to say that this part of the triangle is 500 meters. They attached the wire 5 meters down so it didn't snap in half. So how tall is this triangle? Good, 495. Very good. And they want to know the distance from the tower to the anchor on the ground. All right, guys, this is your point of reference for this triangle. You have an opposite and an adjacent leg. So what are you going to set up for me? Tangent. All right, tangent of our angle that we're working with is tangent of 15 equals opposite over adjacent. This is one of those ones where you're just going to multiply these together. And then to the tens place, please. A little louder, dear. Thank you. Awesome. Now, notice there's a bunch of triangles in that picture, and it just said I want the distance from the tower to one of the anchors. So that other side of the other triangle is going to be congruent. I just don't need to find it. Oh, airplane. Now, this picture is really, really hard to look at, guys. What's happening here is when your pilot is flying the plane, they're up in the sky. And when they say it's an angle of depression, that's basically the angle from their horizon up in the sky looking down at their place where they're going to land. Now, it's way more complicated than what this problem makes it seem. This is not what it takes to be a pilot, by the way. It's way more mathy than this. But for the sake of us, let's make it real simple. Is this angle right here inside my triangle that I have labeled right now? It's not. So here's what's happening. We have the altitude of the plane. Whoops. So here's the plane up here. And they labeled this as the thing I want to find. Well, that's great, but that's not even in my triangle. Is there anywhere else on this picture that would be the same angle? Yes. Alternate interior angles theorem. Very good. So whatever this angle is, it's the same as this angle. And do you remember the name of this angle that's on the ground looking up? Angle of elevation. Good. So really what they're asking me to find is the angle of elevation for that triangle. Okay, we have some labels here, but it's kind of hard to see. The distance, horizontal distance from where the plane is to the landing spot is 5,000 feet. But the altitude is 760 feet. So guys, if this is our angle of reference, we are setting up tangent. So we have tangent of this mystery angle is opposite over adjacent. So how do we find angles again? How do I undo the tangent function? Inverse tangent. Very good. Now, can you please use your brain when you get these answers? Because most common mistake is kids type them in wrong or backwards. Can someone do me a favor who hasn't worked yet? Can you please type that in backwards? Can you do inverse tangent of 5,000 divided by 760? Okay. So what's the right answer, by the way? Okay, 8.6 degrees. So they're saying that the pilot is going to dip the nose of the plane 8.6 degrees down, and that's how they're going to start their landing. Now, who's been on a plane? 8.6 degrees is not a very deep angle, like it's like very slight. What's the other answer that you got when you typed it backwards? 89? What'd you say? 81. That makes more sense. Okay. Okay, so, well, that's 90-degree angle, so we're not doing that, but just slightly better. How would you feel on an airplane
I feel awful.
if the pilot was like, whoop?
My stomach will drop.
Oh, you do a lot more than your stomach would drop. It'd be bad. It'd be bad. Yeah, there's a lot of other issues, guys. So I know, like, geometry teachers always giggle about, like, the answers some geometry kids give them, because they'll get things like 89-degree, 81-degree angle of depression, and they'll be like, really? You think you 81-degree angle of depression? So think about your answers when you're writing them down, okay? Easiest way to avoid mistakes. All right. One more. Oh, I love this question, because I like weather. All right, so in meteorology, a ceiling is defined as the vertical distance from the ground to the base of the clouds. So what they're going to do is they're going to shine a spotlight straight up. And they can measure this distance pretty easily. They just need to walk it. And they know, because also they can measure this, that the spotlight to the actual ground is 1.7 meters. So I think this is like that surveyor question who was trying to find the height of the building. So at the very end, we're going to have to add in this 1.7 meters in a minute. So we'll keep that for a moment. Let's look at this triangle right here. Woo! That was supposed to be a straight line. So clouds are right here. There's something I haven't labeled yet, because I see that this is 150 right here. Where should the x go? Good. The height is what I want. So what trig function are we going to set up if I'm looking for x, and these are the clues I have? So this is the adjacent leg, and this is the opposite leg. So that's O and A. Which trig function uses that? Tangent, TOA. So we have tangent of the angle, 71.5, is his opposite leg over his adjacent leg. So let's cross multiply. Tenths place is good. I can't hear a word you just said. Thank you. 448.3. What's the label on this problem? Meters. So is that my answer? Is that how high the clouds are? Not quite. We have to incorporate this 1.7 meters because that's off the ground. So 450 meters. Awesome. And again, guys, they're clouds. So if you got an answer of like, 11 meters, like that'd be weird. So think about that. All right, guys, that's about all the time I have for the lesson. You guys still have some time, though. You can keep working, maybe setting a few things up.